everybody. So I know this isn't a great video, but I want to show everybody how I write the IUPAC names for aldehydes and ketones as easily and simply as I can. And so I'm gonna do it in my notebook, but I promise it's worth a watch because I have some tips and tricks. So real quick, we'll just look at the difference between aldehydes and ketones. So the main differences here is, first of all, the way that they look. An aldehyde is going to be set up something like this. Whereas a ketone is going to be set up something like this. So, there you go. That's kind of the way they look. And whenever doing this, the main differences to point out here and kind of what you look at in a question to decipher this is this right here. An aldehyde is always going to be bonded to a hydrogen and then double bonded to an oxygen, whereas a ketone always in the middle, not on the ends, in the middle is going to just be a double bond to oxygen. So that's the differences in the way they're set up. And then the differences in the way that they're written out in IUPAC is that aldehydes are going to end in an AL and a ketone is going to end in an ONE. But those are really the only two main differences that I really have to remember whenever doing these problems. So I'm going to give some examples and kind of explain them to you. So yeah, let's get started. Our first example that we're looking at, and this one's pretty easy. So the first thing that we're going to want to decide is it an aldehyde or is it a ketone? Well, we see that here in the middle of our carbon chain we have a double bond to oxygen but no bond to hydrogen. So this is going to be a ketone. We were able to tell because of this right there. So now it gets to writing the IUPAC name for it. So we want to pick out the longest chain of carbons. If you know anything about IUPAC names, this is something that you had to learn to do right from the beginning. So we have this carbon chain of 3 here, and we know that 3 is going to be a propa, because 3 equals prop. And so since this is a ketone, we know that the ending of this is going to be an ONE, so it's going to be propanone. Alright, so then the next thing that we're going to do is we want to find the number that when writing out the IUPAC name, you know, we'll have propanone, but we're going to have a number right here. And how are we going to decide what that number will be? Well, to do this, we're going to want to look at what number on the carbon chain that the carbon is in that is double bonded to this oxygen. Well, we know we want to give it the lowest number possible, but it doesn't really matter here because we have 1 on each side. So let's just do it like this: 1, 2, 3. Well, the propanol is coming off the 2, so therefore we would put 2 right here. And the answer for this would be 2-propanone. The example that we're looking at is right here. So, of course, the first thing that we're going to do is decide, is this an aldehyde or is this a ketone? Well, we see that there's a carbon here that's bonded to a hydrogen and then double bonded to an oxygen on the end of our carbon chain. So we know that this is going to be an aldehyde. Our aldehyde is going to end in AL. I always note that to the side so I don't forget. And so then we want to find our longest chain of carbon atoms. Well, we see a chain of 4 right there. So we know that this is going to be buta. It's an AL ending, it's going to be butanol. Alright, So, the thing about aldehydes here is that you're more than likely never, not more than likely, you will never have a number before them, because they are always on the end. So that will always be first in your carbon chain. So the IUPAC name for this compound is butanol. What I'm going to do here is a little bit trickier, but I wanted to make sure and get this in the video, and that's naming them with attachments. So even with attachments, the first thing we do here is decide is it an aldehyde or a ketone. Well, there's a C bonded to a hydrogen bonded to an oxygen, so we know that it is in fact an aldehyde, so it's going to end in Al. The next thing that we're going to want to look at here is our longest chain of carbons. So we have 1, 2, 3, 4, 5, 6 carbons. So it's going to be a hexanol. And then we're going to want to look at our attachments. We have this methyl group. And we have this methyl group. Alright, so we're going to want to number our carbon chain, and to do this we're going to want to make sure that our carbon that has the double bond to oxygen has the lowest number. So we're going to do 1, 2, 3, 4, 5, 6. The attachments here are at 3 and at 5, so it's going to be 3, 5 methyl. And we don't want to forget, oh, it's going to be dimethyl, actually, I forgot about that, so you're going to want to make sure to put di right here. And the reason for that is because there are 2 methyl groups. So don't forget that, 3, 5 dash dimethyl dash, or no dash, because then we don't have a number coming before our hexanol, so it's just going to be 3, 5 dimethyl hexanol. That's how you write the name. I always appreciate it, and you'll always be getting help on all kinds of fun things. So, goodbye.